In today's lesson, we are going to be looking at collecting like terms. But what we're going to do first, we're going to do a little bit of a warm-up to get us introduced to what this idea actually represents and what it actually means. And it's a little bit easier than you might think. So, for example, say we were doing a Tim Hortons run. So an individual is asking, can I have a large double-double, another large double-double, a large black, a tea with milk and sugar, another large double-double, a maple dip, a large double-double, a large black coffee, and so on. How can I rewrite this order, or how could you rewrite this order to make it easier to place, right? For both the person placing the order and for the person who has to make it. Right? One thing that you could do to make it easier is we have a lot of items that are the same. You see you have a large double here, another one here, another one here, and here. So I have 3 large double doubles. If I go back and look, I have a tea with milk. So there's 2 things there. A large black coffee. I also have a large black coffee down here. I have a tea with milk and sugar. And then on its own, I have a maple dip donut. Actually, let me go use. So we have our large double-double, another one, third one, fourth one. It's actually 4, so we missed one. So 4 large double-doubles. Then we have 1 large black coffee, 2 large black coffees. We have a tea with milk and sugar. And we have a maple dip donut. So rather than going through and ordering each individual item, it's a lot easier to actually combine the ones that we already have, or combine the ones that we have multiples of. Right? So it's a lot easier to say 4 large double doubles, 2 large black coffees, a tea with milk and sugar, and 1 maple dip. So this is a lot easier to order. And it does make sense. We're combining the things that we have multiples of. And that's kind of essentially what collecting like terms is. Let's look at another example. Right? So here is more of like kind of a different version of a mathematical expression, except instead of using numbers or letters, I'm using Tim Hortons items. So I have 2 coffees plus 2 donuts minus 1 coffee plus 4 donuts. So I want to write this order or this expression in a simpler way. What I'm going to do is I'm going to focus on the items that are the same, similar to what I did in the last one. So I got my coffees and I have my donuts. So I'm just going to rewrite this. Instead of coffees, I'm going to put C. Instead of donuts, I'm going to put D. I'm going to group my parts together. So I have 2 coffees minus 1 coffee plus 2 donuts plus 4 donuts. So in total, I have 1 coffee plus 6 donuts. So that is a simplified order to what I just had, or to this above expression. And all I did was I combined the things that were similar. Let's look at a second one. So here I'm going to write this order in a simpler way again. Again, looking at my order, I have 6 cookies plus 2 coffees minus 6 cookies plus 4 coffees. Again, I'm going to focus on the parts that are the same. So the cookies are the same, the coffees are the same. I'm going to group them together. I had 2 coffees plus 4 coffees And I'm going to say maybe they look like oatmeal cookies, so I'm going to use O. So plus 6. Actually, I don't want to use O and get it confused with 0. Maybe they're raisins. So I'm going to do 6R, 6 raisin cookies minus 5 raisin cookies, because that's part of the order. And now what I'm going to do, I'm just going to group them together, or I'm going to add them up. If I have 2 coffees plus 4 coffees, I have 6 coffees. And if I have 6 cookies or 6 raisin cookies minus 5 of them, I'm left with 1 raisin cookie. So again, different ways that we can write these orders, and they're definitely in a more simpler way. It's a lot easier to say 6 coffees and 1 raisin cookie than this expression that I had above. Again, in another example, now I'm dealing with 3 different items: the coffees, the donuts, and the raisin cookies. Again, I'm going to focus on the parts that are similar. I'm going to focus on my coffees. I'm going to focus on the donuts and the raisin cookies. Again, you don't have to highlight and circle or identify which ones are the same. It will be a helpful tip later, but for right now, we can clearly see which ones are similar. So I'm just going to group those parts together. 4 coffees minus 1 coffee plus 3 donuts minus 3 donuts plus 2 raisin cookies plus 1 raisin cookie. Now I can add all of these up. I've just kind of rearranged it just to kind of order things nicely. So if I have 4 coffees minus 1, I end up with 3 coffees. 3 donuts, take away 3 donuts, or plus 3 donuts, take away 3 donuts. Those just cancel out. Those disappear. Basically, if I add 3 and then take away 3, I don't have anything. So 0 donuts. I could put that in there if I wanted to, 0 donuts, but in the end, it doesn't represent anything. Nothing's there anyways. And then finally, 2 raisin cookies plus 1 raisin cookie equals 3 raisin cookies. So my simplified order here is 3 coffees plus 3 raisin cookies. So what we've been doing all along, we've been going through and we've been collecting like terms. We've been collecting items that are similar. So we can do the same thing, except instead of dealing with Tim Hortons orders, coffees and cookies and donuts and so on, we can do that with actual mathematical expressions and looking at letters and variables and numbers and so forth. So if I look at the first expression here, 5D plus 3C minus 3D plus C, I want to write or simplify this expression. So what I'm going to do, I'm going to do a similar thing to what I did with the Tim Hortons orders. I'm going to go through and find the parts that are the same. So I have 5D, and that would be paired up with minus 3D, because those would be similar terms. I also have the 3C and another 3C. So I'm going to group those parts together. I'm just going to rearrange things. And when I'm rearranging things when I add or subtract, I'm allowed to do that. The only thing that you want to make sure is that if, for example, here, when it's minus 3D, I want to include that minus in front, because I want to make sure that I remember that I'm not adding 3D, I'm taking it away. So we have 5D minus 3D plus 3C plus C, or you could say 1C. When I simplify this, I'm just going to focus on the parts that are similar. 5D minus 3D is 2D, or you could say 5 donuts minus 3 donuts, I'm left with 2. And then plus 3 coffees plus 1 coffee, or 3C plus 1C, is 4C. Now you might say, well, why don't I add the rest? Why don't I add 2D and 4C? Well, these are not like terms. I can't combine donuts and coffees. They're two separate items, or they're two separate things. The same thing applies when we're just dealing with a regular expression like 2D and 4C. If I look at the other example, or the next example, I have 4C squared plus 2C minus 3C squared plus 7C. So all I have are C's. But there is a difference. There is a difference between 4C squared and 2C. C squared is different from C. C squared means C times C. Right? If you have to write that down to remember, C squared equals C times C. Well, there's two of them, which is different from 2 times C, or C itself. So C squared does not equal C. So these are separate terms. So we want to be careful of that. We want to make sure that the exponent is the same as well when we're looking for parts that are identical. So I've underlined, or I've kind of highlighted, or I've indicated which parts are the same of my order or expression. I'm just going to group those together just to make it easier to do my next step. So 4C squared minus C, or 3C squared. So again, including the sign in front, plus 2C plus 7C. Again, I'm going to go through and focus only on the parts that are the same. So 4C squared minus 3C squared is just 1C squared, because if I have 4 of something and I'm minusing 3 of something, I'm left with 1 of something. And then plus 2C plus 7C, so 2 of something plus 7 gives me 9 of something. And then again, as we mentioned, I can't add these two together because these are different items. Right? C squared is different from C. So again, this is basically collecting like terms. So when expressions have like terms, and what we mean by like terms are terms that have identical variables. So you could say x, 3x, and 5x. Those are like terms. You could say something like y squared and 7y squared. Those are like terms. You could even say something like 4ab and negative 3ab. Those are like terms because they have the same variables. If I had something that was like 3a, like 3a, say, for example, or maybe even 4b, these are not like terms with any of these. Even though they have part of the variable, so 3a has an a, it doesn't have a b, so it needs to be identical. So for example, in this light blue one, if any like term had a and b as a variable together, they would be identical. If it had only part, it wouldn't. So when expressions have like terms, they can be simplified or made shorter by collecting like terms. So again, that's the term that we're using to basically just mean combining terms. We're just making things shorter. So everything that we've been doing has been collecting like terms. So let's look at a couple of examples. Again, what you want to do, or what's helpful, is draw a line or a squiggly line or something underneath each term to help us figure out which parts are the same. So for example, minus 4d, that's going to be the first term I look for. And now I'm going to look through all the other terms. So 3c squared, nope, c squared is different from d. Plus 2, there's no variable, nope, that's different. Minus d, yes, there is a d there. Doesn't matter that it's minus, right? You could assume that it's still minus 1 in front. The fact is there is only a d, right? So the d's are the same. Next, I'm going to go on to the next one. So if you have to do a different line, maybe a jagged one this time, because you're only using a pencil and you only have one color, that's fine. I'm going to go through and find, is there another term that has c squared? I see at the end. I do. I'm going to include the minus in front. So one thing you might want to make a note of. Include the sign in front. So you include the sign in front. So it's not a plus 8c, it's minus 8c. Next, my next term is plus 2. So now I'm going to look for any terms that only have or that don't have any variables. So that it can also be an indicator of a like term. And in this case, I do plus 4. There is no variable attached to the 4, so that would be considered a like term. Next, I'm going to go through, just for sake of argument, I am just going to rewrite this with things in order. So minus 4d minus d plus 3c squared minus 8c squared plus 2 and plus 4. You don't need to do this step. I'm doing it because it does help, again, just kind of organize and figure out, okay, what am I actually doing? And again, it just makes things a little bit neater. Now I'm actually going to combine my like terms. So minus 4d minus d, or minus 1d. When we're dealing with collecting like terms, all we're doing is we're adding the numbers or the coefficients in front of our letters. So in this case, it's minus 4 or negative 4 minus, as we said, there's a 1 there, so minus negative 4 minus 1. I get negative 5d. You shouldn't ever lose the letter unless whenever you add or subtract, you end up with 0. That d or that variable, whatever that letter happens to be, should always carry over as a placeholder. It should always just kind of remain there. In our next one, positive 3c squared minus 8c squared. Again, the c squared is going to stay. We're not removing, we're not changing anything with that, because that tells us what item we're dealing with, you could say. So plus 3 minus 8 gives me negative 5c squared. And then finally, plus 2 plus 4, or 2 plus 4, gives me 6. So this simplified expression works out to negative 5d minus 5c squared plus 6. One last example. So here's another situation you may come up with. You may be given a object or a shape and asked to write an expression for the perimeter of whatever the shape is. Again, the expression just means something to represent the perimeter. You're not going to be given an actual value, or you're not going to be able to find an actual value for the perimeter in this case, because you can see we have x's included. And we don't know what x represents, we don't know what x equals, so we're just going to be left with an expression. Because we're dealing with perimeter, perimeter equals side 1 plus side 2 plus side 3. Right? Basically, you add up the sides around, or the distances around your object. So in this case, it's going to equal 2x for the one side plus 3x minus 1 plus 3x plus 4. So that's basically a long expression for the perimeter of this triangle. But using what we know, we can simplify this. We can make this smaller by collecting like terms. So I'm going to go through and find which terms are like terms, or which terms have the same variable. So in this case, in the first one, I have 2x. So I'm going to look for other terms that also have 2x. In this case, there's a 3x or a plus 3x and another plus 3x. I still have leftover terms, so I need to go back and make sure they're paired up if possible. It's okay if you can't find anything for that term to pair up with, then you would just leave it on its own. In this case, we have a minus 1 and a plus 4. So two terms that do not have any variables. So when I collect like terms, again, I'm going to rewrite it so that all my like terms are kind of in order. Again, remember to include the signs in front. So minus or -1. From there, I'm just going to add up all my terms. So I have 2 of something plus 3 of something plus 3 of something. That gives me 8 of something. And then -1 plus 4, or -1 plus 4, gives me +3. So 8x plus 3 is the simplified expression for this perimeter. And again, if I knew what x was, I could plug it in and then solve. But right now, this is all I'm going to leave it at. So again, the main thing from this lesson is just understanding what it means to collect like terms and how to do that, what to look for, how to indicate if terms are like or not, and then making sure that we can simplify properly.